So we look at the strength of the polymers. The whole point here is that the polymers that we use in our homes, they have different levels of strength. Okay, so you want to see what determines the strength. Even the polythene bags, you have those that are very strong, and then we have those that can easily get torn. So what makes them to be tough, not easily torn, and then what makes others very weak? So that's what we are going to look at. So let us look at the factors that affect this strength. Remember that polymers are made up of repeating units. So if these repeating units are very many, that means that you're going to have a long chain. Okay, a long chain. The polymer is going to be bigger. And because of that, you expect that the melting point and the strength of that polymer will increase because of the length of the, yes. And then you have those that are branched and those that are straight. Usually, increased branching reduces the molecular strength and lowers the melting point. If it is highly branched, it will not be very strong. So the melting point will always be low and the strength will also be low. So if they ask you between a straight chain polymer and a branched polymer, which one is stronger? Definitely the one that is actually straight is stronger. Okay? And then we come to cross linkage. Remember, the polymers are made up of chains, but these chains, it cannot be one chain. They can be several chains. Now, the connection between one chain to the other is what we call the cross linkage. So the presence of cross linkage makes the polymer to be very strong and very rigid. Okay? And then we have the intermolecular forces. Remember, we are saying that the monomers are actually molecules, but for them they are smaller. And then the polymers are also molecules, but for them they are large. Now, that means that it is possible to have attraction between the molecules. So attraction between one monomer and then the other, that is intermolecular attraction or forces. Now, when you have stronger intermolecular forces, then you will have higher melting point. And that definitely means you have high strength. So look at it this way. When you have two kinds of polythene bags, you get a matchbox. You have that, you can have polythene bag that can easily melt because of that matchbox, and then you have another that will not melt. So the one that will not melt is the one that is stronger compared to the one that will actually melt. Okay, so in this discussion here, we have explained the things that will determine the properties of the polymers. And it's basically the same discussion that we have here. But here the wording is quite different, and I will go through that. So when you're looking at the strength of these polymers, you need to think about the chains that they make. One is, of course, is it a long chain? Is it a short chain? Is it a branched chain? Is it a straight chain? Do you have more than one chain? If we have more than one chain, are these chains connected? Do they have cross linkages? Now, if you answer those questions, you can be able to know whether you're talking about a strong polymer or not. So, if you have a linear chain. That means that it's straight. Okay? When it is straight, it is flexible. Okay? It is flexible. But again, that property of being flexible, flexible reduces there another property, and that property is of strength. Okay? Yes. So it is something that we can say it is a trade-off. If you want flexibility, you may not get strength. If you want strength, you may not get flexibility. Okay? So often thermoplastics are linear chains. They can be melted and reshaped. We shall look at the types of plastics. And then branched chains, here, it means that the chain, the polymer, will actually be less dense, but again, more flexible. And then cross linkages, strength. It provides you strength, but you will have little flexibility. So usually, the Somerset plastics fall under this category. For them, you cannot reshape them once they are set because of the cross linkages between the chains. So the strong polymers, these ones should be cross-linked. The chains should be cross-linked, and because of that, they are very rigid and they are very strong. High strength, okay? High tensile strength, they are durable and they're resistant to environmental conditions. So the PVC is an example of a strong polymer. The pipes that you see here, okay? You use them for piping work, for and also for fittings in construction. Roofing materials, this is polycarbonate. So this polycarbonate is actually here, it is used for greenhouse. But it can also be used for roofing. You can have a shade that is made up of polycarbonate. It's very strong, weather resistant. So we use them in roofing as roofing sheets. And then insulation materials. Okay, this cable, this here, what you see here, that is a polymer, polystyrene. Okay, they are used for electrical and thermal insulation in walls and wiring. They have to be very strong, not weak ones. Flexible polymers, here, they have to be linear or branched, and they don't have to be having strong intermolecular forces of attraction, such that they can be flexible. So that means that they can slide over one another. So you can stretch them, they are flexible, and they are also soft. Nylon and polyester, the examples here.